Hi, my name is Nathan Fryman with Green's Toyota of Lexington, Kentucky, and today I'm just going to give you a little bit of information on Toyota's hybrid technology. But before we jump into the complex components, what is a hybrid? Typically, a hybrid is a combination of two things to create one thing, or a mixture. But in the Toyota world, it's a combination of gasoline and electricity working in harmony to propel the vehicle in a more efficient manner. Starting off, we have HSD, which is an acronym for Hybrid Synergy Drive. And what Hybrid Synergy Drive is, it's a collection of advanced technological and mechanical features that are expertly orchestrated to help move the vehicle. So HSD is the name for the overall system. HSD runs on a very efficient series parallel hybrid system. And what this is the drive wheels here. I know my illustrations aren't the greatest, but the drive wheels on this side, we have the gasoline-powered engine here, electric-powered batteries, and then we have what is known as a power split device. So the engine will give power to the power split device, as well as energy that has been stored in the batteries will also go to the power split device, and these will be blended to create power to move the drive wheels. So now that we have the HSD and the series parallel hybrid system that the HSD works on, we can now move to some of the technology. So firstly, we have two electric motors, and these are motor generators. We have MG1 and MG2. So if you can see here, drive wheels being here, this very first square circle right here is MG1, and this square with the E in it is the gasoline engine. So the gasoline engine and MG1 share a very close relationship because initially MG1 is going to act as a starter, but its primary purpose is to generate power for HVB back here, which are some high voltage batteries. So we have the gasoline engine in close coordination with MG1, and then right next to MG1 is MG2. And what MG2 does is it actually moves the vehicle. MG2 is the electric motor that is directly connected to the drive wheels. MG1 is not directly connected to the drive wheels. So MG2 also gets really involved in regenerative braking. So when you're driving a hybrid and you're coasting, so to say, your foot is off the accelerator but you're gradually deaccelerating, there's a tension in the drive system. And the PCU, which we'll learn down here, turns that tension into energy, which gets stored in these high voltage batteries I was talking about, later used for propulsion. So, the high voltage batteries I was talking about, there are two of them actually. Both are stored back here, and it's able to give and receive energy from both MG1 and MG2. So, first battery we have is an auxiliary battery. And this is going to provide like a continual spark for the gasoline engine. This is like your conventional battery that you would find in a non-hybrid vehicle. It's going to power all the in-cabin electronics, that sort of thing, your basic battery. Then the special battery is the large high voltage battery. And what this does is it's going to output energy for driving at low speeds, specifically under 25 miles per hour is when you'll get the highest blend of electric to gas ratios. So, like I said, it can also receive or give power from MG1 and MG2. So the power from the large high voltage batteries are what is going to power MG2 to move the drive wheels, as well as in coordination with the gasoline engine. So coming down here we have the PCU I mentioned, which is the power control unit. The power control unit essentially is the brain of the operation. What it's going to do is make decisions on the drive system, the amount of energy transfer, etc. So the power control unit sits in the very front. Like I said, or I may have not mentioned, but everything is composed into 5 parts basically. You have the power control unit being one, the gasoline engine, the 2 motors, and the HV battery. So, with the PCU being the brain, there are a couple little things you should also know. In a non-hybrid vehicle, conventionally, the most difficult mechanical part of the drivetrain to operate on would be the transmission. MG1 and MG2 are permanently sealed within a case, which is known as the HSD Transaxle, the Hybrid Synergy Drive Transaxle. So what the Transaxle does, it replaces the conventional transmission. It's a permanently sealed case, like I said, with the 2 electric motors connected by a planetary gear set. And what this planetary gear set, which I tried to draw here, which I epically failed, it's in the middle of the motors, which is causing the revolutions. So the planetary gear set is described essentially as the magic of the hybrid synergy system, connected with the MG1 and MG2 concealed in a transaxle. Now, under normal conditions, the transaxle would never need maintenance, except for every 30,000 miles. There are programs where you should check your transaxle for leaks every 30,000 miles. But, like I said, permanently sealed under normal conditions, they don't need to be regularly maintained. So, what's the point of all of this, right? We know about the hybrid system, we know how it works, and we know sort of why it works, but in real life, what are some dynamics, you know? When you start up the vehicle, you're not using fuel from the gasoline engine. MG1 is going to act as the starter there. And when you're operating at speeds of less than 25 miles per hour, you can opt to drive in what is known as EV mode. And what EV mode is, like an electrical only, or like a high blend of like 90 to 100 ratio of electric to gasoline power. And what EV mode is it's going to use primarily electric for under 25 miles per hour. 25 miles per hour is not that great. Why is that useful? When you're in a parking lot, when you're in a school zone, when you're coasting to a stop, anything of the sort, anything under 25 miles per hour can be handled in all electric. And you'd be surprised, pulling in and out of the parking lots at work, whatever it may be, the daily tasks, it's going to add up. It's, you know, hybrid vehicles are proven to have better fuel mileage simply because of the electricity blend. And you don't need to plug in a hybrid vehicle. There's a common misconception is that you have to charge hybrid vehicles, which that regenerative braking feature we were talking about essentially is the charge, using the tension to create even more energy. It's like an infinite loop of energy in combination with your regular gasoline engine. So these two powers working together is incredibly efficient, and performance-wise, you're really not going to miss out on that much, because electrical motors these days are giving out some of the fastest acceleration known. Some of the fastest acceleration comes from electric motors, and gasoline is better for a vehicle already in movement and just propelling forward. So I hope some of this information helped you. I hope it was somewhat organized.